All right, it's recording. It is good to go. So we're just gonna, like I said, we're gonna go through and we are going to do just the odd numbered problems here on the Trig review that is listed on Google Classroom. So it starts with a pretty basic one that you know how to do, the Pythagorean Theorem. So we'll just roll right through that one. 9 squared plus 12 squared equals, normally we say c squared, but in this case we'll say x, just because that's what they gave us. Okay, and then we just take each number and we square it. Add them together. And then you take the square root of that number to figure out what we need. Okay, so remember, if you want to undo a square, you use a square root. And you end up getting x equals 15. Okay. All right, one down. We good so far? I'm having trouble hearing anyone. I don't know if anyone's talking or not, but it would let me know if you were, I would think. Oh, well, we'll figure it out.
I hear you.
Let's go on to problem number 3. Now, this one is going to be a little bit different for a couple of different reasons. One reason is it's not going to come out pretty. It's going to come out really ugly. The other part of it that causes trouble is you've got a missing side that isn't the longest one. So we're going to have to put the x in the other place. Whenever you're using the Pythagorean theorem, the longest side always goes last. So in this case, the 14 is going to have to go last. And we're going to have to set it up like this instead. Okay, so when you actually set it up, you're going to end up getting 100 plus x squared equals 196. And so again, what's going to make this different is you're going to have to take away 100 from both sides instead. And then you're going to get x squared equals 96. And just like we did on the last one, we're going to have to take the square root of both sides. Now hang on, I'm going to try something a little different here. So I have a calculator that I downloaded, and I like it. Some people didn't, but I like it. Here I'm going to start sharing something different. There you go. All right. So I wanted to show you this because this is the calculator that I like using. Okay. And you do the square root of my wife telling the dog to not do something, I'm guessing. Oh, apparently it would be my son. All right, whatever. Not a lot I can do at the moment. Okay, square root of 96, and it did say in the directions to round to the nearest tenth. So you get x equals 9.8. Oh boy. All right. Sorry, I got a little bit distracted. Okay, let's move on here. Susan leaves her home and she walks 6 miles north and 2 miles west. How far away is she from her house? I don't know about all of you, but that just seems like our life story here in the last 2 months. We do a lot of walking around. We're all over the place, which is good. So Susan walked 6 miles north. And then 2 miles west. Now, if you are not good at these directions, it's not really a big deal because you're going to get the correct answer no matter what you do. How far away is she from her house? Round to the nearest tenth. Well, that would mean we would want to know the direct distance. And that would mean that right there. All right, so let's do it. We're just going to do the same thing we always do. 6 squared plus 2 squared equals, it doesn't matter what you call it, squared. And then we can get that calculator out again. And this time we're going to do the square root of 40. You get 6.3. This was a word problem, so I'm going to give it a label. 6.3 miles. Okay. All right, I'm going to unmute everyone for just a second. I just want feedback. Are we doing okay so far? Okay. Okay. All right, let's jump back in here. Do the 3 sides listed below form a right, acute, or obtuse triangle? So this is where we learned a different trick. You can take the Pythagorean theorem, and if it turns out to be greater than on the left, then that means it's an acute triangle. You see, the Pythagorean theorem only works on right triangles. So if the number on the left is greater, that means it's acute. If the number on the left is less than, then it's obtuse. That did not come out how I wanted it, but that's okay. And then if it's equal to, then obviously we knew it was going to be a right triangle all along. Okay. The cheesy phrase that I use is GTA, Grand Theft Auto, greater than acute. Okay, that's the phrase that I use to remember it. GTA. All right. All right, thanks for joining us. And yeah, you can write this on notebook paper if you want. Just make sure you take a picture of it. It's all good. All right, so let's go through number 7 here real quick. 5, 12, and 13. So basically, you plug in the numbers from smallest to largest as if you're doing the Pythagorean theorem, and then you just give it a test, okay? All right. Thanks for joining us. We are currently on problem number 7, and we're talking about the different ways that you can test to see what kind of triangle something is. In this case, if you were to test out 5 squared, 12 squared, and 13 squared, you get 25, 144, and 169. Is that going to be greater than, less than, or equal to? So you add the 25 and the 144, and you end up finding out that you get 169 on both sides, which means it was equal. And if it's equal to, then that means it's a right triangle. So again, greater than means acute. Less than means obtuse. And then if it comes out equal, then it's right. All right, so we are done. Hey, thanks again for joining us. We now have a few new participants. So we have done the review that was provided to you on the Google Classroom. You can go take a look at that if you want. We have done 1, 3, 5, and 7. And we're just going to keep on going. And we're just going to go through all of the odd numbers on that review. Okay. All right, and then we're going to go on to number 9. Let's go through. All right, find both missing sides in the special right triangle. Leave your answers in simplest radical form. So here's the deal. Whenever you see a right triangle that also has a 60-degree angle, that's because it was half of an equilateral triangle. That's why it comes out to be a special right triangle. And if it's half of an equilateral, then that means this guy right here has to be 7. Because if it's equilateral, then that means all of these big sides are 14. And if you know the whole thing is 14, then that means half of it is 7. Now, the part in the 30, 60, 90 triangle that people forget is what to use for the height. And the shortcut is you can take whatever the little guy was and you can tack on a radical 3. So y is 7 radical 3. Okay. Now, you're not always going to remember that, but if you do, it saves you from having to do any Pythagorean theorem stuff. You can just remember it. And if you can just remember it forever, it'll help you not only now, but a couple of years from now when you do more math later on that relates to trigonometry, geometry, whatever. In fact, I sometimes do it with my Algebra 2 kids, but that's another story for another day. Let's slide over to number 11. This one comes down to the fact that if you ever have two of the same angle, then you will also have two of the same side, which means y is also 12 inches. Now, whenever you get this special kind of triangle, the shortcut for this one isn't radical 3, it's radical 2. And that's another one where if you did the Pythagorean theorem, you would find that out. But it saves you so much time to not do it that it's much better just to get the shortcut down. So that was the 45, 45, 90 triangle. And I didn't make up that special rule. That's something you can find online anywhere you look. Okay. Just like the other one was the 30, 60, 90 triangle. Okay. All right. Let me check the chat here, check participants. Those of you just joining me, I'm on two different things right now. I'm on my phone and I'm on my computer because the computer that allows me to share the screen does not have a camera. So I'm just sort of all over the place. So thank you for your patience. I really appreciate it. Okay. Number 13. Remember, we're doing all the odds here. So on number 13, this time they gave you the part that had the radical 3, so you have to kind of think backwards. Not a big deal. If you remember, it's half of an equilateral triangle. So you can just kind of work backwards and say, oh, well, I guess that means we're going to put the 9 right there. And then if it's half of an equilateral triangle and you have 9 and 9, then that means y equals 18. Okay. All right. Looks good to me. I believe that completes the front side. Those of you who have the paper on you and are watching this right now with the paper in front of you, that completes the front side if I remember right. All right. So let's just keep on going. We're doing good here. The length of a diagonal of a square is 20 centimeters. Find the length of one side. Okay, so the length of a diagonal is 20. Find the length of one side. So there are two different ways to do this problem. We know that a square has two matching sides on each corner here. Obviously, a square has 4 equal sides, so we know that these two match. So we have two options. We could either call these x and then solve with the Pythagorean theorem, or we could use the reverse of our 45, 45, 90 trick from before. Okay, so you have two different options. It's really up to you. The reverse would be, instead of multiplying by the square root of 2, you divide by the square root of 2. But we haven't practiced that a lot. So if you know that trick, that's fantastic. If you don't know that trick, follow along with me, and we're just going to go through it the long way really quick. It's actually not going to be that long. All right. 20 squared is 400. Divide both sides by 2. So you get x squared equals 200. Now I'm going to kind of flash back here to the days where you had to simplify radicals. I'm just going to throw that out there because 200 would really just be 100 times 2. And the square root of 100 is 10. So you could actually just call your answer 10 radical 2 centimeters. Now there is a shortcut. Some people are like, well, couldn't you just divide by 2 and then put the square root of 2 on? I've heard people say that before. Yeah, that's true too. There are a few different ways you could have approached that problem. So I don't really care which one you chose as long as you chose something. All right, now we're going to get into that right triangle trig business, that sine, cosine, tangent stuff that I know everybody just absolutely loves. Now, whenever you do that, we have to sort of assign what we know, what we don't know. Now, if you're not feeling great about the trig ratios, this was what we did in trig lesson number 2. We've practiced it a bunch, but if you need to go back, you can definitely go back. The angle that we've been given is 38 degrees. Okay. And the side we've been given is the side that's farthest away. As in, we know the opposite side. I put K there, as in that's the side that we know. The side that we want to know is the adjacent side. Adjacent just means sort of your next door neighbor. Now, math people have created the cheesy phrase to help us remember which operation to use. Sohcahtoa. Sine, cosine, tangent. It's just a cheesy phrase that helps us remember what's going on. In this case, because we're using O and A, we're going to use that one, which would be tangent. Your calculator does it. Any calculator that's worth more than about 10 bucks can do it. But we have to make sure we do the order correctly. We put opposite first. And then adjacent last. And then we have to solve. Okay. Now I just cross multiply here. And don't freak out about the way it looks. Because the truth of the matter is the tangent of 38 is really just a number. It's really just something that you could throw into your calculator and get a number. It's really not a big deal at all. So since we know it's just a number, let's just divide both sides by it and get it over with. And we'll get our answer. So x equals, and then we're going to get our calculator out. Now, whatever calculator you use, I'm okay with it, as long as you double check and make sure that that calculator is using degrees. Okay, degree mode is the most important thing, and most of these calculators have a mode that can be changed. So anyway, from there, we'll just take care of it. 12.5 divided by the tangent of 38. Boom, we're done. And we're just going to round that and call it 16.0 because it came out to 15.999. So we'll just go with that. Okay. All right, just a few more, and then you'll have earned your odd numbered problems here. Let's go to number 19. So for 19, the angle that they gave us was 61 degrees. The thing that we know is the adjacent. The thing that we want to know is the one that's farthest away. That's the opposite. And according to our cheesy phrase, this is going to be another. If we want O and A, we're going to choose tangent. So tangent of 61 equals, and this time, if we keep opposite first, adjacent on the bottom, this time it's actually going to be easier because if we cross multiply, 1 times x is just x. And then 5 times the tangent of 61, I don't know what that is, but I'm going to figure it out. All right, 9.0. Looks good to me. So it was actually just sort of a coincidence that we ended up using tangent both times there. We're doing odd numbered problems, and so it just worked out that way. On number 18, for example, I'm not going to do number 18, but just for example, the thing that you know is the hypotenuse, and the thing that you want to know is the opposite. So that would have actually been a sine problem, because it has O and H in it. All right. Looks like we're rolling here. We just have a couple more minutes left here. We just have a few more problems. So we'll go to, I'm going to do a bonus one. I'm going to do 20 and 21 here. So for number 20, this time around, the things that we know are the adjacent and the hypotenuse. But the thing that we want to know is the angle. Whenever the angle is the thing that's missing, we use the inverse operation. Okay, I'll show you what I mean by that here in just a second. If we go with our cheesy phrase, and we've got adjacent and hypotenuse, A and H, that means we're going to do cosine. So we're going to say cosine of x equals, the adjacent side is 8, the hypotenuse is 15. So the way we're going to deal with that, we can't just use the regular cosine to get this one right, because the angle is what's missing. So what we have to do is get our calculators out and find the option that gives you the little -1 thing. Okay, so let's put this up here. On this calculator, it's got a second button in blue. And if you hit the second button and then the cosine button, it gives you 8/15 right there. It gives you the inverse function. That's just the one that has a little -1 on it. And by doing that, it allows us to find that missing angle instead, which in this case, round to the nearest whole degree is what it said. So that means we're going to go with, if we just follow directions, 58 degrees. Okay. Now that was your bonus one, just because I wanted to make sure we do an example of something other than tangent. On 21, we know the opposite and we know the adjacent, which is why I had to do a bonus problem. It's because we're doing tangent again. Tangent of x equals opposite over adjacent, which is 13/16. So now instead of doing the inverse thing with cosine, we're going to do the inverse thing with tangent. There you go. Let's put it up here, see what we come up with. Inverse tangent of 13/16. It did say round to the nearest whole degree. So we're going to go 39 degrees, which is about how cold it was last night, which is ridiculous. Somebody forgot to tell us it was May, but I'm not bitter. Okay, I'm a little bitter. Okay, I'm very bitter. Oh my goodness. All right, let's wrap this up, and then if we have any individual questions or we just want to talk about whatever, we can. I can leave the window up real quick. Write the simplified ratio in each blank. So number 23, sine of A. So there you go. Sine is opposite over hypotenuse. So if you're focused on angle A, the opposite is 8. The hypotenuse is 10. So 8 over 10. Now, unfortunately, that's not actually the correct answer because it said simplified ratio. That means you need to reduce to 4 over 5. Just divide the top number by 4, the bottom number, or the top number by 2, the bottom number by 2, and you get 4 over 5. All right, cosine of A. So that would be k. There you go. Sohcahtoa. Cosine is adjacent over hypotenuse, so we're going to go 6 over 10, which also needs reduced, and we're going to reduce that down to 3 over 5. All right, and then last but not least, we've already used this one how many times? I have no idea, but we've got TOA. That means we're going to go opposite over adjacent, which is going to be 8 over 6, which is going to simplify down to 4 over 3. All right, so what I'm going to do is stop the recording here. So if you're watching the recording, thanks. I appreciate it. And if you are here right now, then that would be a great opportunity for you to ask any individual questions. All right.
Since you did the odds, do we have to do the evens to get points? Or is that just like not a thing?